Okay, so now it's exercise 3. So the first question is the length of the chord of contact of the circle x squared plus y squared equal to 10x with respect to the point -1, 1 is. Uh, okay, so this can be written as minus oh x minus 5 squared plus y squared equal to, so you will have 25, right? So 5 squared. So the circle is like this. It has its center at 5 comma 0. Okay, and it has radius 5, and this is some point -1 comma 1, and we only need the distance between the center and this point, which is going to be the square root of 6 squared plus 1 squared, so 36. Yes, that's correct. So it's square root 37, I guess. Yeah, that looks correct. Okay, so now let's just deal with geometry. So you got a point which is square root 37 distance away from the center, and you got the radius 5. Okay, so if I draw this chord, uh, this is a tangent, so here it's perpendicular, so this thing is going to be 37 minus 25, which is 12. So 12 square root of that. Okay, and this thing, oops, what is this? Okay, so this another tangent that will also be square root of 12, and this is 5, and we are interested in the chord of contact, so you got a perpendicular over there. Okay, what should we do now? Oh, let's just use area. So square root 37 times chord of contact, call this L upon 2, right? So this thing is L upon 2. This should be equal to 5 times square root 12, right? Because the area of this triangle. So that means L is 10 square root 12 upon square root of 37, right? Square root 12, that's just 2 square root 3, so this is 20 square root 3 upon square root of 37, right? Let's just hope that this is actually correct, right? Where was I? So what's the length of the chord of contact? It is 20 square root 3 upon square root 37. I mean, that's what we think it is. We don't know if it is correct. Next question. The locus of the point, the locus of the point, the chord of contact of tangents from which to the circle. Okay. Oh, okay. So the locus of the point from which, so this should be first, from which the chord of contact to the circle x squared plus y squared equal to a squared subtends a right angle at the center is a circle of radius. Okay, cool. So wait a second. The locus of the point from which the chord of contact of tangent to the circle subtends a right angle at the center. Oh, that's easy. So you got this chord, and it is subtending 90 degrees. Okay, maybe I should do it like this would be better. So this is subtending 90 degrees to the center, right? So this thing is r, this thing is r, this thing will be r square root 2. So square root 2r, cool. And we want to find what this distance is. This is going to be, I think this is going to be 1 by, okay, so this is r by square root 2, right? And you got this point, and this is also perpendicular, so this should also be r, this should also be r. This complete distance is also going to be square root 2r. Hey, that's pretty easy, because the distance from this point to the center, that's always going to be square root 2r. So this is a circle of radius r square root 2, right? This was easy geometry, nothing difficult. Polar of the point 2 comma 3 with respect to the circle x plus 2 square plus y squared equal to 5 is. Okay, so the polar of the point with respect to this circle. That's weird. uh, I think I forgot how to find polars. It was t equal to 0 if I correctly remember. Yeah, for the chord of contact at least it was t equal to 0. So in general too it was t equals to 0, I think. Okay, so first of all let's just simplify this. So this is going to be x squared plus 4x plus 4 plus y squared equal to 5. So x1, yeah, x1, so 2x plus 4 into, I think it was x plus 2 upon 2, right. This is minus 1, so minus 1 plus y1, so 3y equal to 0. This line should be the polar, right? I hope so. uh, so this is going to be 4x. What am I doing? You got 2 over there, right? 2x plus 2x plus 4 minus 1 plus 3y equal to 0. So 4x plus 3y plus 3 equal to 0. Let's just hope that that's actually the equation. Next question. The line 5x plus 4y equal to 1 meets the circle x squared plus y squared equal to 9 at P and Q. Point of intersection of tangents at P and Q is. Okay, this line meets this circle at P and Q. Point of intersection. Okay, let's just draw this first of all. So what? This is really bad. Okay, that's better. So it's some line 5x plus 4y equal to 1. This is a circle x squared plus y squared equal to 9. And this meets the circle at P and Q. Point of intersection of tangent at P and at Q is. So these are going to intersect somewhere over there, I guess. So call this R maybe. So that point of intersection is, oh, so this line is actually the chord of contact of this circle. No, wait, of R with respect to the circle. In other words, it's polar. Yeah. So let's just say that this has coordinates h comma k. So now let's just find the polar the polar of h comma k with respect to this circle, right? So h times x plus ky equal to 9. Yeah. So over here h is 5, k is 4, and 9 is 9. No, wait a second. Oh, so we cannot just do that, we have to compare maybe. So h upon 5 is equal to k upon 4 is equal to 9 upon 1. Yeah, that's better. So h is 45, k is 36. Cool. So what do we need to find? We want to find h comma k. So 45 comma 36. Next question. If the middle point of the chord of contact x squared plus y squared plus x minus y minus 1 equal to 0 be 1 upon 2 and 1 upon 2, then the length of the chord is, okay, middle point of a chord of the circle be 1 by 2 comma 1 by 2, then the length of the chord is, okay, so we just need to find the radius and the center, and that will be it. Yeah, nothing big. Okay, so x plus 1 by 2 squared plus y minus 1 by 2 squared equal to 1 plus 1 by 4 plus 1 by 4 is 1 by 2, alright, which is 3 by 2, which is also r squared, right? So 3 by 2 equal to r squared. The center is negative 1 by 2 to negative 1 by 2 comma 1 by 2. R squared is 3 by 2. Okay, so you got a circle like this. This is negative 1 by 2 comma 1 by 2. This point is, okay, so this is not necessarily on the circle, so this point is 1 by 2 comma 1 by 2. So this distance has to be 1. Okay, The radius is square root of 3 by 2. So what's the length of the chord? So this distance, that's going to be 3 by 2 minus 1. Yes, that's correct. Which is 1 by 2, so the square root of that. So this is also square root of 1 by 2 by symmetry. So 2 times square root 1 by 2, that is square root 2. That should be the answer. Let's move on. The equation of the chord of the circle bisects the point. Okay, bisected at the point 2 comma 1 is. Okay, chord of the circle bisected. I don't get it. Oh, so it has the midpoint 2 comma 1, and we want to find the equation of the chord of this circle. Okay, so how do I do that? Bisected at the point. Well, I guess I will have to do it using common logic now, because there is really no other way. I cannot remember anything from any lecture. I mean, I didn't attend most of the lectures, so yeah, that's my fault, but still. Okay, the equation of the chord of this circle, right? So let's draw the center over here. What's the center going to be? It's going to be it is equal to 10x over there, isn't it? So x squared minus 10x plus y squared equal to 0. So x minus 5 squared plus y squared equal to 25. So this is 5 comma 0. Okay, it is bisected at 2 comma 1. So this is some point 2 comma 1, and it is bisected like that. So you just have to find the equation of this chord, which is actually perpendicular to this line. So that's gonna be easy. So what's this slope? This slope is 1 upon 1 minus 0 upon 2 minus 5, which is negative 1 upon 3. Okay, so negative 1 upon 3 reciprocal and negative, that's 3. So y minus 1 upon x minus 2 equal to 3, y minus 1 equal to 3x minus 6. So y minus 3x plus 5 equal to 0. Cool. Where was I? Yeah, y minus 3x plus 5 equal to 0. That should be the equation. Okay, the middle point of the chord of the circle x squared plus y squared equal to 25 intercepted on the line x minus 2y equal to 2 is. So it's, I think they mean something like this. So this is a circle. Okay, let's just draw a better circle. This is the circle and this is a line. Okay, this line is x minus 2y equal to 2. This circle is x squared plus y squared equal to 25, and you got two intercepts, right? And they are asking about the midpoint of this chord. Okay, cool. So I think I know how to do this, right? I've done these kind of problems once. So let's just write x equal to 2y plus 2 first of all, and let's put this thing into that. Okay, so 4y squared plus 8y plus 4 plus y squared equal to 25, right? Okay, so 5y squared plus 8y minus 21 equal to 0. So y1 plus y2, that is minus 8 upon 5, which means y1 plus y2 upon 2, that thing is minus 4 upon 5. So now we know the y coordinate of this midpoint. So it's minus 4 upon 5. Right, so these have x1, y1 and x2, y2 as their coordinates, right? So clearly this equation must be satisfied. Clearly this equation must be satisfied by these 2 points, right? Okay, let's try for x2. So x1 and x2. So we can write okay, y equal to x minus 2 upon 2. Okay, where was the equation of the circle? X squared plus y squared equal to 25. So x squared plus x minus 2 squared upon 4 equal to 25. Multiply by 4, 4x squared plus x squared minus 4x plus 4 equal to 100. So 5x squared minus 4x, okay, minus 96 equal to 0. So x1 plus x2 equal to minus 4 upon 5, which is 4 upon 5. So x1 x2 upon 2, that is 2 upon 5. This should be the coordinate, right? And actually I discovered this method recently when I was dealing with some questions on parabola. So this method is much more efficient than any other method because it directly gives us the coordinates of the midpoint. And I see that they keep on asking questions about the midpoint. So if we can directly find the midpoint from just the equation, I guess that's a good thing. I don't know if this is a correct method or not, but let's just go with it. Find the combined equation of two tangents drawn from point 3, 0 to the circle x squared plus y squared equal to 4. Combined equation of two tangents drawn from the points. Alright, combined equation, well that's weird. Okay, combined equation, I don't get it. Let's just try doing it. So you got something like this, you got a circle, right? X squared plus y squared equal to 4, and you got a point 3, 0. Okay, so maybe over here. So let's just draw it picture perfect. This should be 3, 0, and we want to draw the tangents passing through this point, and it should be the combined equation of those. That is very weird. I don't know what do you mean by the combined equation. I'm just gonna find both equations because I do not understand what you are trying to talk about. What do they mean by combined equations? Yeah, whatever. So let's just say this point is, oops, what happened? 4. Okay, maybe we should not be doing that. Okay, so let's do it like this, like y minus 0 upon x minus 3 equals to m. So y equal to mx minus 3m. Okay, cool. Yeah, that's the equation of tangents with m. So nice. And that's gonna be y minus mx plus 3m equal to 0. This has center 0, 0. So the distance from the center to this line, that's going to be 3m, actually the magnitude of that, upon square root of 1 plus m squared, and this distance should be equal to the radius, which is 2. So magnitude of 3m, I think that's what they mean by the combined equation. Okay, why did I put a 1 over there? It's not necessarily a 1. Okay, I don't know if that's a combined equation though. Yeah, that's very weird. We just find both of them in that case, right? It was passing through 3, 0. Okay, so let's just square this. So 9m squared equal to 4 plus 4m squared. So 5m squared equal to 4, m equal to plus minus 2 upon square root of 5, right? So y upon x minus 3 equal to plus minus 2 upon square root of 5. So y square root of 5, actually plus minus y square root of 5 equal to 2x minus 6. So 2x plus minus y square root of 5 minus 6 equal to 0. Maybe that's the combined equation. Okay, so 2x plus minus y square root 5 minus 6 equal to 0. Okay, two tangents to the circle x squared plus y squared equal to 4 at points A and B meet at minus 4, 0. The area of the quadrilateral PAOB where O is the origin is. Okay, so you got a circle once again. This is x squared plus y squared equal to 4. Right, this is the origin 0 comma 0, and you got a point minus 4 comma 0, so this is going to be somewhere over here. Right, this point is minus 2 comma 0, this point is minus 4 comma 0. Okay, right, and the tangent from this point, these are intersecting this circle at A and B. This is A, this is B. Okay, this distance is 2, this distance is 2. What's this distance? This distance should be 4, right? Yeah, that distance must be 4. Looks like I've seen this somewhere. Yes, I've seen this somewhere. This angle should be 30 degrees because sine, right? So this is 90 degrees. So sine 30 degrees is 1 upon 2. So this is in the ratio 1 upon 2. Cool. So this is also 30 degrees. Yes. So this is 60 degrees. That is whatever. We just have to find area, right? Yeah. What's this length going to be? This is going to be square root of 3 upon 2 into 4. So that should be 2 square root 3. Similarly, this is going to be 2 square root 3. So the area of this triangle, that is 2 square root 3 into 2 upon 2. And then 2 times of that because the lower triangle 2. So that's going to be 4 square root 3. That's the area. Cool. The angle between a pair of tangents drawn from a point P to the circle x squared plus y squared plus 4x minus 6y plus 9 sine squared alpha. What is this equation? Is 2 alpha. Okay. The equation of the locus of the point P is, oh, so the angle between the tangents is 2 alpha, and this is the equation of the circle. This is weird. Okay, the equation of the locus, the point is, I mean, we really only need I think we only need the distances, right? Yes, we only need the distances, because I think P is going to be lying in another circle of a bigger radius, right? So you got a circle. This circle is x squared plus y squared plus 4x minus 6y plus 9 sine squared alpha plus 13 cosine squared alpha equal to 0. Okay, so this can be written as x plus 2 squared plus y minus 3 squared equal to 2 squared plus 3 squared is 4 plus 9 is 13. 13 minus 9 sine squared minus 13 cosine squared. Okay, so this thing is r squared, isn't it? Cool. This angle is 2 alpha, which means that this angle must be alpha. This angle must be alpha. Okay, right, so this is the center of that circle. So let's just say that maybe this angle is alpha. So this radius, this should be, right, so r upon this distance d, actually call this capital R. This should be sine alpha, isn't it? Right, this is sine alpha. Cool. Yeah. What else? Right, so we know the value of r now. Okay, so small r squared upon capital R squared equal to sine squared alpha, and we know what small r squared is. It's actually just 13 minus 9 sine squared minus 13 cosine squared. Actually 13 minus 13 cosine squared is 13 sine squared, and 13 sine squared minus 9 sine squared is 4 sine squared upon capital R squared equal to sine squared. So this cancels. Just get r squared equal to 4, so r equal to 2. That's nice. So it's going to be the same thing, just with capital R over here. So that's going to be 4, right? Not all this stuff, it's just 4. So yeah, that's it. That should be the equation of the locus of point P. Let's just simplify this. So x squared plus 4x plus 4, that gets cancelled, plus y squared minus 6y plus 9 equal to 0, right? X squared plus y squared plus 4x minus 6y plus 9 equal to 0. That's for this question. Okay, so now to the 11th question. Maybe I should try talking less, because why not? The area of the triangle formed by the tangents from point 4, 3 the circle x squared plus y squared equal to 9, and the line joining their points of contact is, okay, the area of triangle formed by the tangents from the point 4, 3 this to this circle. This is x squared plus y squared equal to 9. Okay, so the radius is 3. And this point is 4, 3. We got a 4, 3 point. This is 0, 0. This distance is 5. Okay, this is like the tangent stuff. So this should be 4, and this should be 4, and this is 90 degrees. So that's pretty easy. It's just 2 times of half into 3 into 4, right? Because yeah, so that's going to be, this gets cancelled, so 3 times 4 is 12. That was a little too easy. I was not, okay, whatever. The locus of the midpoint of those chords of the circle x squared plus y squared equal to 4, which subtend, didn't we just do that? It's subtend a right angle at the origin is, okay, I think we just did that. So it's just going to be another circle, right? So it's just going to be another circle, it's another concentric circle, and this, oops, this is the center 0, 0. Here's the midpoint. This is 2, this distance is 2, okay, and this angle should be 90 degrees. Oh wait, actually this does not look like it's 90 degrees, so let me just draw a little better. So this angle is 90 degrees. This is 2, this is 2, this should be what? This should be square root 2, right? Yeah, so this circle, this another concentric circle, is having radius square root 2. So x squared plus y squared equal to 2. That should be the locus. Next, let the circles, okay, be intersecting in the points P and Q. Point of intersection of tangents at S2. Okay, tangents to S2 at P and Q is, that's weird. Tangents. Okay, at least we know what the chord of contact is in that case, right? So this is the circle. This is S1, this is S2, and they are intersecting at P and Q. We know the equation of this line PQ, don't we? It's just the radial axis. So if I subtract these away, yeah, that's going to be equal to minus 4x minus 6y minus 3 minus 4, so that's plus 1 equal to 0. So 4x plus 6y equal to 1. That is this line, okay. And this circle is x squared plus y squared equal to 4. Cool, we got this line, and what they are saying is that P and Q, if we draw the tangents at P and Q for this circle S2, and they're going to intersect at some point R, we have to find the coordinates of that point R. So let the coordinates be h comma k. Then using t equals to 0, we can find the equation of PQ, right? So that's going to be hx plus yk equal to 4. So let's compare. h upon 4 is equal to y upon 6 equal to 4 upon 1. So h equal to 16, y equal to 24. So that should be it. It should be 16 comma 24. Yeah. Next question. Okay, let's delete this. Next question. How many of them? Okay, so not that much. That the equation of circles of radii 1 touching the circles x squared plus y squared minus 2 mod of x equal to 0 are. Okay, that's weird. The equation of circles touch of radii 1 touching the circles. How are these two circles? That's weird. Okay, so should we take two cases in that case? Circles of radii 1. I mean, I really didn't get the problem. What are we being asked? So you got two circles which are represented by this equation, and we want to find equations of circle of radii 1 touching the circles. Huh? That doesn't make sense. Like, okay, so these have radii 1 and they should be touching the circles. That's all that they have given us. So are we supposed to find a general equation? Well, if that is correct, then it's going to take a lot of time to do that, right? Or do they want us to find the equation of the circle touching both of the circles at the same time? Maybe that's what they want us to find, because I guess there will be at max two circles that can do that, right? Yeah, correct. So that must be the thing which they are asking. Okay, so what circles are these? Okay, so let's take some cases. If x is bigger than 0, actually bigger than or equal to 0, then this equation essentially becomes x squared plus y squared minus 2x equal to 0. So x minus 1 squared plus y squared equal to 1, right? So let's graph that. It should be at 1 comma 0, so that's where it is. The radius is 1. Oops. So radius is 1, which means this is the circle that they are talking about, and this is 1 comma 0. And then you have another circle which is x plus 1 squared plus y squared equal to 1, which should be this one, right? Yeah, and this is minus 1 comma 0. Okay, so now we got these two circles, and we want to find the equations of the circle of radius 1 touching both of these circles. Yes, that's correct. Okay, so one of them must be something like this. Okay, and another one must be something like this. So now how do we do this? Well, first of all, maybe we should work on the lengths. So this thing is 1, this thing is also 1. Let's say this has the center over here. Call this r. This is also r, right? We don't know anything else. Do we know about its coordinates? Maybe. No, we don't. This distance is also 1, right? So this distance is also 1. I mean, they are touching over here. Okay, so these two circles are touching. This distance is 1, right? We don't know anything about that distance. Oh, this is r for sure. But what about this? Okay, this is weird. Yeah, I don't get it. Wait a second. Can't r be anything? I mean, think about it. If r were to get to infinity, at that point you will be getting a line, right? So that surface is going to look something like this. If r is something a little less than that, it's going to look something like this. Yeah, so R can be anything. So what are the, how are we supposed to find this? Wait, this is not possible. We cannot just find it using, wait, this equation, no. Oh, okay, radius 1. Ah, ah, that that's understandable. Okay, so they did give us the radius already. So it's 1, right? So this is 2. This thing is 1, which means this length, it should be square root of 4 minus 1, which is square root of 3. So this point, this is going to be x is 0 and y is square root 3. And by symmetry, the center of this circle, it should be 0 comma minus square root 3. Okay, and the radius is obviously 1, so that's pretty doable. So for this circle, x minus 0, so x squared, plus y minus square root of 3 squared, that is 1 squared is 1, so x squared plus y squared minus 2 square root of 3y plus 3 equal to 1, so x squared plus y squared minus 2 square root of 3y plus 2 equal to 0. And for that lower circle, x squared plus y squared plus 2 square root of 3y plus 2 equal to 0. So this means that the equation of those two circles is x squared plus y squared plus or minus 2 square root 3y plus 2 equals to 0. Cool. This was weird, very weird. Okay. Okay, the next question is, if the distance from the origin to the centers of three circles, x squared plus y squared plus 2 lambda, okay, 2 lambda I x minus c squared equal to 0. Oh, so I can be 1, 2, 3, which means lambda 1, lambda 2, lambda 3 are 3 values of lambda. And distances from the origin to the centers of these three circles are in GP. Then the length of the tangents drawn to them from any point on this circle are in. Oh, that's very weird. Okay, let's try it. So first of all, let's see what we can do with this equation. So x squared, actually x plus lambda squared, right? So x plus lambda squared, ouch, my hand hurts, plus y squared equal to c squared plus lambda squared, right? So this center is minus lambda comma 0. Okay, right, are in GP. Then the lengths of tangents drawn to them from any point on this circle are in. Let's, okay, so we got a point minus lambda comma 0 as the center. Okay, and this is on the x-axis, yes, and it has radius squared equal to c squared plus lambda squared. Okay, this is very weird. So this distance is lambda. Okay, and this is the center most likely, right? This is 0 comma 0, and c squared plus lambda squared should be a little bigger than this, so it's going to be somewhere over here. Okay, so this should be the circle. Cool. And what have they given us? So we are also considering this circle, which has radius c squared and is centered around 0 comma 0, so that should be this circle, right? So this has radius c, this distance is lambda. Okay, and then they told us that if these distances are in GP, then the length of tangents drawn to them from any point on this circle are in. Oh, that's weird. Wait a second. There could also be the chance that maybe it's over here, right? Yeah. So this is if lambda is positive, but what if it's not positive? Okay. If it's not positive, um, in that case minus lambda comma 0, it's going to lie somewhere over there, right? And then you still have c plus c square plus lambda square, so c plus lambda, right? So c plus magnitude of lambda, that as the radius, and then it's still c squared. So I guess this could also be one of the possibilities, right? And yeah, that okay, so that would also be a very similar case. So another similar case is if you have this circle. Okay, so if you have this circle, I don't know, I'm drawing very bad. So this is centered at lambda, actually minus lambda comma 0, right? Then this distance is lambda, this distance is c, and then you do the same stuff. So that also is the same thing as that. So yeah, we will just consider one case and not all of them. Okay, so now they have asked draw tangents from any point on this circle to that circle, and guess what, only this is the point from which if we draw a tangent to this circle, it will from which we draw a tangent to this bigger circle, right? Okay, so that is the tangent which they are talking about, which is, so this should be c comma 0, so this is going to be equal to x equal to c. Nice. So what next do they want to find? Oh, okay, then the length of the tangents drawn from any point on the circle are in. What do you mean by the length of the tangent over here? Okay, this is not making any sense now. So this distance must be c, that must be minus lambda comma 0, this c squared plus lambda squared is r squared. Oh, sorry, so r is not, it's not like c plus lambda whole squared. What am I doing? So this distance, this is not necessarily c, so yeah, that's not very correct. So okay, so is this gonna be intersecting or what? I mean, it has to be intersecting, right? Yes. Okay, so this is really bad. I don't know, it's not correct. Yeah, so this thing is lambda, this thing is not, this is not c, and the circle is going to look something like that. Okay, right, that's what happened. Just what happened? Uh-oh, just a minute. What is happening? No. Okay, whatever, I'm just gonna cut it now. Oh, we can actually do this. So I just want to bring this to the front. I don't know, just cut it. I'm also gonna delete all this. Okay, so this is still there. Okay, let's start fresh now. So where were we? Yeah, this 15th question. Okay, so let's just draw it up once again. So this is minus lambda comma 0, then you also have something like that, right? So this is c plus lambda, that is the radius. Okay, this distance is lambda, So it has to be something bigger than that, right? Yeah, so it has to be something like this. Ah, this is really bad. Okay, so that should be the circle which we are talking about. And this point is the center, it is minus lambda comma 0, and it has c square plus lambda square as r squared, so this is slightly bigger than lambda. And then you got another circle centered around here, and this is going to have c as its radius, so this is going to be something like that. Okay, this is once again a bad circle. Yeah, this is better. Okay, so now what else does this tell us? So length, right, so the distance from the origin to the centers of the three circles are in GP. Okay, so that pretty much means that lambda 1, lambda 2, lambda 3 are in GP. Cool. What else? Then they are asking about the length of the tangents from any point on this circle. So let's just choose a random point, say this, and we can call this point, let's parameterize this. So this is going to be c sine alpha, c cosine alpha. Okay, and then we draw tangents from really please don't do it. Then we draw tangents from this point to this bigger circle. Okay, and then they want us to find those lengths first of all. Okay, this is getting bad already. How do we find those lengths? You got any way of finding those? Well, let's just find this distance first in that case. So that has to be c sine alpha plus lambda squared plus c cosine alpha. I should not write sine alpha cosine alpha like this. Squared, and the square root of that, this is going to be square root of c sine squared alpha plus 2c sine alpha lambda plus lambda square, and then sine squared alpha plus cosine squared alpha is 1. So nice. Right. Anything else? So that's this distance. This distance is the radius, which is square root of lambda squared plus c squared. So what's this distance going to be? It's going to be the square root of this thing square, which is c plus 2c sine alpha lambda plus lambda squared, minus of this thing square, which is minus lambda squared. Actually this should be squared over there, right? Yes, that's lambda squared minus c squared, so this cancels. So just get square root of 2c lambda sine alpha. So that is this distance, right? So because sine alpha, this is a fixed quantity now, we can just write it like this. So lambda square root of 2c sine alpha. So this is a fixed quantity, so lambda 1 and this thing, then lambda 2 and the same thing, and lambda 3 and the same thing. Those are the lengths of the tangents, and guess what, they are obviously in GP. So much for so little. I just hate this 15th question. I mean, why did I put take over like that? 16th, find the polar of point 4 comma 4 with respect to the circle x minus 1 squared plus y minus 2 squared equal to 1. Polar of point 4 comma 4 with respect to this circle. Yeah, that should not be a big deal. So really it's just x squared minus 2x plus 1 plus y squared minus 4x plus 4 equal to 1. So this cancels. You get x squared minus 2x plus y squared, this should be y, minus 4y plus 4 equal to 0. You want to find the polar, so just put that in there. So 4x minus x plus 4 plus 4y minus 2 times of y plus 4 plus 4 equal to 0, right? So this is going to be 4x minus x is 3x minus 4 plus 4 minus 2y is 2y minus 8 plus 4 equal to 6 is minus 4. 3x plus 2y minus 8 equals to 0. That should be the polar. Next question. The equation of the chord of the circle x squared plus y squared equal to 8x bisected at the point 1, 1 is. Okay, this is a chord bisected at 1, 1 and want to find the equation of this. Okay, standard stuff. So yes, x minus 4 squared plus y squared equal to 16. Yeah. So 4 comma 0 is the center, and then you got this 1 comma 1 as the midpoint. So join those, and this is the chord which we are looking for. And what's the equation of that chord? So perpendicular, this slope is 1 upon minus 3, so the slope is 3. So 3 equal to y minus 1 upon x minus 1. So y minus 1 equal to x, 3x minus 3. So 3x minus y minus 2 equal to 0. That should be it. Okay, 3x minus y minus 2 equal to 0. 17. The equation of the chord. Oh, that's the 17th question we deal with. 18th. The coordinate of the point of contact of the circles x squared plus y squared equal to 2 and x squared plus y squared minus 6x minus 6y plus 10 equal to 0, which touch each other externally are what? Coordinates of the point of the contact. This circle and that circle, which touch each other externally. Points of contact. What are they talking about? So they mean these two circles touch each other externally? Yes, maybe. And then find the coordinates of the point of contact, basically. Right, that shouldn't be that big a deal. Yeah. Alright, so just find the ratio. Just find the radius first of all. So over here the radius is square root 2. Over here, let's start with like x minus 3 squared plus y minus 3 squared equal to minus 10 plus 9 plus 9 is 18, so 8, right? So over here it is 2 square root 2, so this should be in ratio 1:2. So you got this circle and you got this bigger circle, okay, and they are touching each other. So this thing is square root 2, this thing is 2 square root 2. Okay, so these are in ratio 1:2. Okay, this center it is 0, 0, and this center is 3, 3. Cool. So where are they intersecting? Right, so the x coordinate is 3 into 1 plus 0 into 2 is 0 upon 3, so that's 1, and the same thing, right? So 3 upon 3, so this has to be 1, 1. That is where they are intersecting. Cool, that's it. Okay, what's the other thing? Either this is the point of contact or it is the midpoint of their common chord, whatever. So the next thing which is touch either externally are, yeah, so it's 1, 1. Anything else? Any other question? No, that's it. So cut this. Let's check our answers. So let's start with 18th. 1, 1 is correct. 17th. Yes, that's correct. 16th. Correct. 15. They just wrote GP. Oh, yeah. Okay, so they asked us what these are in. Okay, I thought it was prove that they are in GP. So GP. Okay. 14. 14 is also correct. 13th. 16 comma 24. 12. Yes, correct. uh, and then 11. Wait, 192.25 square units. What? Tangents from the point to the circle and line joining there. Oh wait. Oh, okay. So I I solved it in a very wrong method. So what we found out was the area of his quadrilateral, which was not what we were supposed to find out. We were supposed to find out his area actually. So we solved the wrong thing. Yeah, and that's why we got the wrong answer. Okay, so 11th is wrong. Fine. 10th. The angle between a pair of tangents. Why am I reading this? 10th is x squared plus. Yeah, that's correct. Okay, 9th. 2x. Oh, 9th is 4 squared. So that's also correct. 8th. 4x. Just wait a second. 8. Find the combined equation of the tangents from point. That's not what I got. Huh. Wait a second. This is not even an equation of a circle. Combined equation of two tangents, right? So 8. For 8 they gave us a circle. That doesn't make sense. Oh, okay, so I think I understood what they actually did there. So this is actually correct. This is the combined equation of those two tangents, but they did something like this. They must have done something like this. 2x minus 6 plus y square root 5. I think this is called pair of straight lines, right? I just hate it when people do this thing. Okay, so this thing squared is 4x squared plus 36 minus 24x, right? And then plus, actually not plus, this should be minus, I guess. Yes, minus 5y squared equal to 0, which is correct. That's what we got. So yeah, 8th is actually correct. 7th, middle point of the chord of contact, sorry, so 2 upon 5 and minus 4 upon 5. Yeah, that's correct. 6th, what is this 2 doing over here? 6th is correct. Yeah, this 6th is correct. 5th, square root, wait a second, length of the chord is why is this 1 upon square root 2? We were asked the length of the chord, isn't it? Right. The middle point, so the center of this should be minus 1 upon 2 comma 1 upon 2. So that distance is 1, right? And what's the radius? The radius is 1 plus 1 by 4 plus 1 by 4, which is 3 by 2. Right, that's r squared. So r is square root of 3 by 2. And then that thing is 1. So that should be 1 upon 2. Now that should be square root 2. Length of the chord is in fact square root 2. I don't know why they gave us 1 upon square root 2. That doesn't make sense. Right, so r squared is 3 by 2 for sure. Okay, this distance between the midpoint of that chord and center, that is 1. So 3 by 2 minus 1, that is 1 by 2. So the square root of that, right, that's 1 by 2 and 1 by square root 2, and 2 times of that should be square root 2. So that's not the length of the chord. It's actually half the length of chord that they give us. So I guess their solution is actually wrong. I don't know. Fourth, yes, it's correct. Third, polar of the point, yes. So 4x plus 3y plus 3y, that's correct. Second, square root 2 into a. Okay, so yeah, so over here r is a because x squared plus y squared equal to a square. So that's correct. First, 20 square root 3 upon square root 37. Yes, that's correct. Okay, so I guess it was okay, not really fine, but I guess I will do it with that. And these were 18 questions. This 15th one was uh, the wording is not very good, and yeah, whatever. I will see you in the next video.